Objective-C Part 2 Basics. Welcome. Hello viewers, welcome again to my tutorial video and also in the world of iOS app development. Today we'll focus on some more basic topics and data types. Basic syntax. Semicolons. In Objective-C program, the semicolon is a statement terminator. That is, each individual statement must be ended with a semicolon. It indicates the end of one logical entity. For example, following are two different statements. NSLog, hello world, semicolon. So here semicolon ends this line and return 0 semicolon ends this line in here. Comments. Comments are like helping text in your Objective-C program and they are ignored by the compiler. There are two types of comments. First one, it starts with double slash. This is applicable for single line comment like double slash. This is my first project. So this is my first project line will be totally ignored by the compiler. Second one, it starts with slash star and terminate with the characters star slash as shown below. So between this, my first program in Objective-C, this whole line will be ignored by the compiler. This is best for multi-line comment. You cannot have comments within comments and they do not occur within a string or character literals. Identifiers. An Objective-C identifier is a name used to identify a variable, function, or any other user-defined item. An identifier starts with a letter capital A to Z or small a to Z or an underscore followed by 0 or more letters and digits from 0 to 9. Objective-C does not allow punctuation characters such as at, $, and percentage within identifiers. Objective-C is a case-sensitive programming language. Thus, capital N power and small manpower are two different identifiers in Objective-C. Always use meaningful name for identifiers, which can really explain the work of the identifier. Here are some examples of acceptable identifiers. First underscore name, first capital N name, create table view, here T and view are capital, and move underscore object underscore to. Naming rules. Objective-C properties and variables name should start with noun, verb, or adjective. Like in here, title is noun, shows alpha, shows here verb, shows title, shows verb. So for defining constants, always use block letters like hash define screen height. Here screen height is block letter 300. So the value of screen height is 300. Method. Name should start with a lowercase letter and capitalize the first letter of embedded words. For methods that represent actions and object text, start the name with a verb. Like in here, invoke with target. Invoke is verb. Select tab view item. Select is verb. White space in Objective-C. A line containing only white space, possibly with a comment, is known as a blank line, and an Objective-C compiler totally ignores it. White space is the term used in Objective-C to describe blanks, tabs, new line, characters, and comments. White space separates one part of a statement from another and enables the compiler to identify where one element in a statement, such as int, ends and the next element begins. Therefore, in the following statement, int space age. So the space here is separating the int from the age. There must be at least one white space character usually a space between int and age for the compiler to be able to distinguish them. On the other hand, in the following statement, fruit space equal space apples space plus space oranges. No white space characters are necessary between fruit and equal or between equal and apples, although you are free to include some if you wish to improve your readability. So here we use the spaces for better readability. Data types. Objective-C has two categories of data types. First, remember that Objective-C is a superset of C. So, you have access to all of the native C data types like character, int, float, etc. Objective-C also defines a few of its own low-level types, including a Boolean type. Let's call all of these primitive data types. Second, Objective-C provides several high-level data structures like strings, arrays, dictionaries, and dates. These high-level data types are implemented as Objective-C objects. Since these are all defined in the Foundation framework, we will call them Foundation data structures. I am going to cover both primitive data types and most important Foundation data structures in this tutorial. By the end of this chapter, you should have a solid grasp of every data structure you could possibly need for your Objective-C programs. Displaying values. In addition to data types, we will also learn a lot more about NSLog string formatting in this chapter. This will let us display variables of all sorts in the Xcode console, which is an indispensable skill for debugging applications. To print any data in the Xcode console, we can use NSLog. Inside the bracket, we use percentage symbol to designate placeholder values. NSLog will fill them in with values passed as additional parameters. For example, the %add in the following code is replaced with the ename variable. So NSLog hello %add my name is Hal, comma a name. So if a name is equals to Tom, then you will see the output in the console as hello Tom, my name is Hal. Objective-C programs use the bool data type to store Boolean values. Objective-C also defines its own true and false keywords, which are yes and no respectively. To display bool values via NSLog, use %i in the format string. Like bool is human equals no. So NSLog it's alive, %i, comma is human. The %i specifier is used to display integers. So this should output it's alive equals 0. As we know, no equals 0, yes equals 1. Tips. While checking bool condition, it's better to check in the following way, like if bracket is human instead of if bracket is human equal yes. Objective-C uses the same character data types as ANSIC. It denotes a single byte signed integer and can be used to store values between -128 to 127 or an ASCII character. To display a character as an integer, just use the generic %i specifier introduction in the previous code sample. To format it as an ASCII character, use %c. So, character letter equals quotation mark Z. NSLog, the ASCII letter %c is actually the number %i letter. So the output will be the ASCII letter Z is actually the number 122. So as with all integer data types, it's possible to allocate an unsigned character. which can record values from 0 to 225. Instead of the %i specifier, you should use %u as a placeholder for unsigned integers. Unsigned character tiny int equals 255. So NSLog, the unsigned character is %u tiny int. The result will be the unsigned character is colon 255. Short integers are 2-byte signed integers and should be used for values between negative 32768 and 32767. To display them with NSLog, use the %hi specifier. The h is the modifier for the same %i used in the previous two sections. For example, short int little int equal 27000. NSLog, the short int is %hi little int. Unsigned shorts can be created the same way as unsigned characters and can hold up to 65535. Again, the u in HU is the same one as %u for generic unsigned integers. Unsigned short int u little int equal 42000. The unsigned short integer is %hu u little int. Hello, good afternoon. Tamanna here. Hi. Yes, I am. Good, thanks. How are you? Normal integers. Next on the list is int, which is a 4-byte integer on most systems. Again, remember that data type size is system dependent. The only way to know for sure how big your data types are is to use the size of function. NSLog %lu size of int. If your int type is indeed 4 bytes, it can hold values between negative 21474836648 and positive 2147483647. Int normal int equals 1234567 NSLog. The normal integer is %i normal int. This also means that the unsigned version can record 0 to 4294967295 numbers. If int isn't big enough to meet your needs, you can move up to the long int data type, which is 8 bytes on most modern systems. This is large enough to represent values between so long number you can see Long integers can be displayed via NSLog by prepending the letter 1 to the %i or %u specifier as shown in the following line. So long int, big int, something something, NSLog, the big integer is %li, big int, so unsigned long int, u big int, something something, the even bigger integer is lu, u big int. The idea behind having so many integer data types is to give developers the power to balance their program's memory footprint versus its numerical capacity. Floats. Objective-C programs can use the float type for representing 4-byte floating point numbers. Literal values should be suffixed with F to mark the value as single precision instead of a double. Discussing in the next section. Use the %f specifier to output floats with NSLog. Float some real number equals 0.42f. NSLog, the floating point number is %f some real number. You can also specify the output format for the float itself by including a decimal before the f. For example, %5.3f. It will display 3 digits after the decimal and pad the results so there are 5 places total, useful for aligning the decimal point when listing values. Doubles. The double data type is a double precision floating point number. For the most part, you can treat it as a more accurate version of float. You can use the same %f specifier for displaying double in NSLog, but you don't need to append f to literal values. Double and the real number equal 0.42. NSLog, the floating point number is %5.3f and the real number. Structs. Objective-C also provides access to C structs, which can be used to define custom data structures. For example, if you are working one graphics program and interact with many two-dimensional points, it's convenient to wrap them in a custom type. So, to do this, we can use type-def struct. Second bracket starts float x semicolon, float y semicolon. Second bracket closes point 2d semicolon. The type-def keyword tells the compiler we are defining a new data type. Struct creates the actual data structure which comprises the variables x and y. And finally, point 2d is the name of the new data type. After declaring this struct, you can use point 2d just like you use any of the built-in types. For instance, the following snippet creates the point 10.0, 0.5 and displays it using our existing NSLog format specifiers. Point 2d p1 equal bracket 10.0f, 0.5f. NSLog, the point is at bracket %1.1f, %0.1f, p1 dot x, p1 dot y. The 10.f and 0.5f notation is called a compound literal and it can be used to initialize a struct. After initialization, you can also assign new values to a struct's properties with the equal operator. So p1.x equal negative 2.5f, p1.y equals 2.5f. Arrays. While Objective-C provides its own object-oriented array data types, it still gives you access to the low-level arrays specified by ANSIC. C arrays are a contiguous block of memory allocated when they are declared, and all of their elements must be of the same type. Unlike C hash arrays, this means you need to define an array's length when it's declared, and you can't assign another array to it after it's been initialized, because there are no way for a program to automatically determine how many elements are in an array. There is no convenient NSLog format specifier for displaying native arrays. Instead, we are stuck with manually looping through each element and calling a separate NSLog. For example, the following code creates and displays an array of 5 integers, like int sum values, third bracket 5 equals second bracket 15, 32, 49, 90, 14, second bracket closes and semicolon. So for int I equals 0, semicolon, I is less than 5, semicolon, I plus plus. That means the loop will start from 0 until the I value is less than 5. It will continue. NSLog, the value at index %i is %i, I, some values I. So it will print out for each I value, like from 0 to 4, as its I limits to less than 5, the value of the array. That is for like the value at index 0 is 15. Then the next one will be the value at index 1 is 32, like this. As you can see, C arrays look much like atomic variables, except you have to provide their length in square brackets. They can be initialized with the same compound literal syntax as structs, but all the values must be of the same type. Individual elements can be accessed by passing the item number in square brackets, which is common in most programming languages. In addition, you can access elements via pointers. Pointers provide a low-level way to directly access memory addresses in a C program. And since C arrays are just contiguous blocks of memory, pointers are a natural way to interact with items in an array. In fact, the variable holding a native array is actually a pointer to the first element in the array. Pointers are created by prefixing the variable name with an asterisk. For example, we can create a second reference to the first element in the sum values array with the following code. Int sum values 5 equals second bracket 15, 32, 49, 90, 14, second bracket closes. Int asterisk 6 pointer equals sum values. Instead of storing an int value, the pointer variable points to the memory address containing the value. This can be visualized as the following. So the pointer is locating to 15, the first index of the array. To get the underlying value out of the memory address, we need to difference the pointer using the asterisk operator like so. In a slog, the first value is %i asterisk pointer. This should display 15 in your output panel, since that is the value stored in the memory address pointed to by the pointer variable. So far, this is just a very confusing way to access normal int variable. However, things get much more interesting when you start moving pointers around with the ++ and - operator. For example, we can increment the pointer to the next memory addresses as follows. Pointer ++. So in slog, the next value is %i asterisk pointer. Since an array is a contiguous block of memory, the pointer will now rest at the address of the second element of the array. As a result, the nslog call should display 32 instead of 15. This can be visualized as the following. Pointers provide an alternative way to iterate through an array. Instead of accessing items via the square brackets, you can simply increment the pointer and dereference it to get the next value, like this. Pointers have innumerable uses in high-performance applications, but in reality, you probably won't need to use pointers with native arrays unless you are building a data-intensive application that is seriously concerned with speed. However, pointers are still very important to Objective-C programs because every object is referenced through a pointer. This is why all of the data structures in the upcoming Foundation Data Structures section are declared as pointers. NS number, star, some number, not NS number, some number. Void. The void type represents the absence of a value. Instead of typing variables, void is used for functions and methods that don't return a value. For example, the say hello method from the previous chapter didn't return anything, and it was thus defined with the void data type, void say hello. Nil and null. The nil and null keywords are both used to represent empty pointers. This is useful for explicitly stating that a variable doesn't contain anything, rather than leaving it as a pointer to its most recent memory addresses. There is, however, a strict distinction between the two. The nil constant should only be used as an empty value for Objective-C objects. It should not be used for native C style pointers. Blah, 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 blah. Void. The void type represents the absence of a value. Instead of typing variables, void is used with functions and methods that don't return a value. For example, the say hello method didn't return anything, and it has thus defined the void data type, void say hello. Nil and null. The nil and null keywords are both used to represent empty pointers. This is useful for explicitly stating that a variable doesn't contain anything, rather than leaving it as a pointer to its most recent memory address. There is, however, a strict distinction between the two. The nil constant should only be used as an empty variable value for Objective-C objects. It should not be used for native C style pointers, int some pointer. Null can be used for either primitive pointers or Objective-C object pointers, though nil is the preferred choice. Next to come, foundation and data structures. Thank you for watching. Don't forget to subscribe for more. Bye bye.